So now we look at the third question from this diverse SDE sheet, that is the threesome. So what the question says, we are given an integer array nums. We have to return all the triplets, that is nums of I, nums of j and nums of k, such that I is not equals to j, I is not equals to k. So all the indices are distinct and nums of I plus nums of j plus nums of k equals to 0. Okay, so we have to return just a triplet such that they all are different, because they are pointing to they all should be pointing to different indices, and they add up to form 0. Okay, so we are given an array, and we have to return array of array as our out. So we are just have to return a array of triplets that add up to form 0. Okay, so how will we try to solve this question? So now we'll discuss how we'll try to solve this question. So what we have to do, we have to find the triplet. We have to find the triplet that add up to form the sum as 0. Okay, so what we'll do, we'll make use of the three pointers that will first starting from the start, that is the first index of the array, second from the I plus 1, and the third from the j plus 1. Okay, so we'll loop over the array till the last point. Okay, loop over the array, and we'll check for each of the triplets that add up to form the sum as 0, and we'll maintain a set in which we store the triplets that have their sum equals to 0, because we have to return the unique triplets now. So we will take use of the set and store these triplets in a sorted manner. We'll sort the triplets before storing into the set. We'll sort it and store into the set and get the unique triplets that add up to form the sum as 0. Okay, so this approach requires a time complexity of order of n cube to using three loops. Okay, three nested loops, and it also requires a time complexity of log m to store the elements in the set. Okay, and a space complexity of basically n n. This approach will require a time complexity of order of n cube log m, where m is the number of triplets, and a space complexity of order of m. Okay, so how can we optimize this? Because this is a nice solution to solve this problem. So can we optimize this? Yes, we can. So what is the optimized solution for this approach? What we can do, let me copy the array. So what we are trying to do here, we'll use a two pointers approach. Okay, two pointers approach. The prerequisite of two pointer approach, we need a array in a sorted manner. Okay, the first thing we'll do, we'll sort the array. Okay, we'll sort the array. So now our sorted array will be -4, -1, -1, 0, 1, and 2. Okay, now we'll iterate over the array using one loop, and we'll take use of the two pointers. Okay, two pointers. The one will be pointing to S will be pointing to I plus 1, and E will be pointed to n minus 1, where n is the size of the array. Okay, so we'll look for the sum as minus 4 plus minus 1 plus 2 will add up to, that is 3 minus 3. So it is less than 0, so we'll move our start pointer to the next position. Okay, now now its value is minus 3, that it's because the start is currently pointing to minus 1, so the sum will be minus 3. Okay, we move our start to the next position. Now what will be our sum? Minus 4 plus 0 plus 2, it will be equals to minus 2, so it is less than 0, so we'll move our start to the next position. So start will be here, so now we'll calculate a sum will become minus 1, so it is still less than 0. We'll again move our start to the next position, and now is the two pointers conditions terminate, because the two pointer conditions is such that while s is less than. Okay, now what we'll do, we'll move our ith pointer to the next position, that will move to this position, and our start to here and to here. Now what we'll do, we'll again find the sum. Our sum now become equals to 0, and because we have found a triplet, so we'll store the triplet minus 1 minus 1 2. Okay, we'll store the triplet, and what we'll do, we'll make our start pointers point to the unique, because we don't a unique element, because we don't want our start we don't want any duplicacy in our triplet. Okay, so we'll make this start points to this next element, next unique element. So we'll make our endpoint to this. Now we'll calculate our sum. It is minus 1 plus 0 plus 1. Again the sum become equals to 0. Okay, we again found a triplet. Okay, we again found a triplet, that is minus 1 0 1. Okay, now what we'll do, we'll again move our start to the unique element, but when we move start to the next position, this condition will get will get violated. So what we'll do, we'll move the index I to the next element, that is minus 1. So what we'll do, we have found our answer using this. So what we'll do, we'll make our ith pointer points to the unique element. We don't want any duplicacy in our triplet, so we don't want any duplicate element to be considered twice. So what we'll do, we'll skip this, because these and the previous ith value, that is this one, and I plus 1 are both same, so want we want unique elements in our triplets. So what we'll do, we'll make our ith pointer points to the next element, that is to this. Now again our start will be here and will be here, so we check sum is 3, so we'll decrement our e will point to this. Now our condition will get terminated. Now our I would be pointing to this, and start would be pointing to this, and end would be pointing to this. Now our condition get terminated. So our conditions got terminated, and we have found only two triplets. Okay, so what is the time complexity to solve this problem? So we'll require order of n log n time to sort the array, plus what else time complexity do we require? Log n, that is the loop that we will use to traverse the array in a two pointers approach. Okay, and we are not using any set or anything, so time complexity would be the same, and space complexity would be order of 1. Okay, so this approach looks very nice to us, because previously we are solving it in order of n cube log m, and now our time complexity is reduced to order of n square. So our time complexity and space complexity in the previous cases order of m, and in using two pointers approach our time complexity is order of m. So this is how we try to solve the question 3 sub. So now we look at the code. Now we try to look at the code. So we have a function named 3 sub that will return vector of int, and it has received an input array. So what we are doing in the function, we are maintaining our answer uh, vector of int. We are checking a condition. If the number of elements in the input array is less than 3, so we cannot form any triplet. So we just return the empty answer. Okay, empty vector of vector. Now, if the number of elements is more than 3, so what we'll do, we'll sort our array. And what we'll do, we use a loop to iterate over the array. Okay, we use a loop to iterate over the array and maintain the two pointers. One will be pointing to I plus 1, and the back will be pointing to nums dot size minus 1. And what we'll do, we have maintained the condition of the two pointers while front is less than back. We calculate the sum. If the sum is less than 0, we will increase the front. If the sum is greater than 0, we will decrement the back. If sum become equals to 0, we have found our answer. We will push the triplets in our answer, that is vector of int, and we make our front point to the element that unique element because we do not want any duplicacy in our triplet. So we make our front points to the unique element and make our back points to the unique element. Okay, and we also don't want our ith element to again points to a duplicate element, so we make ith points to the unique element. So this is the approach to solve the problem. At the end we'll return the answer. Okay, so this is the code for the question. Okay, if you have any doubt, please feel free to ask.